In this video, we are going to look at the CSEC Math January 2024, Paper 2, Question 9. Now, in this Question 9, Part A, we have K, L, M, and N are points on the circumference of a circle with center O. So we see in the circle here, we see in the center O, and we see in the K, L, M, and N. Obviously, this quadrilateral, which is a four-sided shape, all the vertices touch the circumference of the circle, which would make K, L, M, N a cyclic quadrilateral. Then we have XY is a tangent to the circle at K. So we have the XY being a tangent to the circle at K, meaning this tangent touches the circle at K. And we know from O to K is the radius, and the angle between the tangent and the radius is a 90-degree angle. Then we have angle LKY is equal to 48 degrees, which is shown here. Then we have angle MKO is 12 degrees, which is shown here. And then we have angle XKN, which is 56 degrees, which is shown here. Now, question A, part 1, we want to find the value of angle KOL, giving reasons for each step of your work. So let's highlight angle KOL. Okay, so we have K to O and then O to L. So this is the angle that we want to find. Now, we've seen that this angle is at the center of the circle. And if you remember the rule for the angle at the center of the circle, we know the angle at the center of the circle is twice the angle at the circumference. Now, if we look at the chord or the arc that this angle is standing on, the chord would be KL, and the arc also is K to L. And therefore, if you look at the angle at the circumference that stands on the same chord, that would be this angle here. So this angle stands on the same chord KL as this angle. This one is at the center and this one is at the circumference. So this one at the center will be twice this angle here at the circumference. Now the thing is, we don't know what this angle is. Now there's another rule that says the angle between a tangent and a chord is equal to the angle in the alternate segment. Now we've seen that we have this tangent here from X to Y, and we have this chord KL, and the angle between the tangent and the chord is 48 degrees here. So now we are looking for the angle in the alternate segment. Now that angle in the alternate segment must be touching the circumference of the circle. So below KL is your minor segment, and above KL is the major segment. So the 48 degrees is sort of in the minor segment. So the angle in the alternate segment has to be the one in the major segment. And as I said, the vertex of that angle must touch the circumference of the circle. So again, you are looking for an angle that's standing on the chord KL that's touching the circumference of the circle. And that angle is right here. Therefore, if here is 48 degrees, then here is also 48 degrees. All right, so let's write our reason for this angle being 48 degrees, which is, angle between tangent and chord is equal to the angle in the alternate segment. So I'll write angle KML. So angle KML is equal to angle YKL, which is equal to 48 degrees. And my reason, angle between tangent and the chord is equal to the angle in the alternate segment. All right, so that's my reason for this being 48 degrees. And now that we know here is 48 degrees, we know this angle here must be twice that angle. So angle KOL will be 2 times 48, which will be 96. So angle KOL, which is equal to 48 degrees times 2, which is equal to 96 degrees. And your reason for that would be angle at center is equal to 2 times angle at circumference. All right, so that will be our answer for angle KOL, and we gave reasons for each step of our working. So I'm just going to write here is 96 degrees. All right, so next for part A, part 2, and then part A of that part 2, we have to find the value of each of the following angles, and that first one is angle LMN. So we are going from L to M to N. So that's L to M, and then M to N. And this is the angle that we want to find. Now, what I'm noticing about this angle is that, I'm seeing a cyclic quadrilateral. So I'm going to highlight that. So I'm going to highlight here and highlight here. Now, the thing about a cyclic quadrilateral is that the opposite angles are supplementary, and supplementary means add up to 180. So if I highlight this entire angle here, this whole angle, right, just forget about the 12, this whole angle from angle NKL, this whole thing, plus this angle here, angle NML or LMN, all right, must add up to 180 degrees. Now, the thing is, how do we get this whole angle? All we know is this 12 here. Now, here we have a straight line, and we have here as 56 and here as 48. Now, we know the angles along a straight line must be equal to 180 degrees. So, the 56 plus 48 plus this whole angle here must be equal to 180 degrees. So, all we have to do is add up the 56 and 48 and take it away from 180, and we'll get this angle here. And this angle will be NKL. So, angle NKL is equal to 180 degrees. Take away 56 degrees plus 48 degrees. And that's equal to 180, take away open brackets, 56 plus 48, close brackets, and we get 76. All right, so this is 76 degrees. Therefore, this whole angle is 76 degrees. And as I said, the opposite angles of a cyclic quadrilateral are supplementary, meaning they must add up to 180 degrees. So angle LMN, all right, angle LMN will be equal to 180 degrees, take away 76. All right, so 180 take away 76 is equal to 104. So angle LMN is equal to 104 degrees. Now notice for this question, they never told us to write a reason for our answers. But because this is a teaching moment, I'll write the reasons. So for this one, the reason would be straight angle. And for this one, I'll write the opposite, OPP for opposite, angles of a cyclic. I'll put QUAD full stop, which is short for quadrilateral. So opposite angles of a cyclic quadrilateral are supplementary. I'll put SUPP full stop for supplementary. All right, so this is your answer for angle LMN. It's 104 degrees. Now for part B of part 2, where we have to find the value of each of the following angles, we have angle KLO. So that'll be K to L to O. So that's K to L and then L to O. So this is the angle that we want to find. Now, I'm looking at this. And remember, up here was 96 degrees. Let's put that in. Here was 96 degrees. Now, O to L is the radius, and O to K is also the radius. So, OK and OL are equal to each other. Therefore, this triangle here would be an isosceles triangle. So let's just connect and form the triangle. And I'll put a dash on this side like that, a dash like that, to show that these two sides are equal to each other. And if I had to write a reason for that, I would put that, OK is equal to OL, and the reason for that would be radii, right? The plural of radius. So now, what do we know about an isosceles triangle? Well, we know that the base angles of an isosceles triangle are equal. So this angle is equal to this angle here. So that'll be this angle here. And we know the sum of the interior angles of a triangle must add up to 180 degrees. So what I could write is that angle OKL is equal to angle OLK, because the base angles of an isosceles triangle are equal. So angle OKL is equal, the angle sign here, to angle OLK. And my reason, base angles of an isosceles triangle are equal. So now we can say, 180 take away 96 and then divide our answer by 2, and we get these two angles here. So angle KLO is equal to 180 take away 96 divided by 2. So I have open brackets, 180 take away 96, close the brackets, and then divide by 2. And we get 42 degrees. So I'm going to write 42 degrees. So here's 42, and here's also 42. All right, and that will be my answer for angle KLO. What I get right here for a reason, since I already have the base angles of an isosceles triangle are equal, is that the sum of the interior angles of a triangle is equal to 180 degrees. All right, so sum of interior, INT full stop for interior, angles of a triangle is equal to 180 degrees. And that'll be my reason. So now for part C, we want to find the value of angle MLK. So that's MLK. Let's highlight that. All right, so angle M to L and L to K. All right, so that's this angle here. All right, so what I'm seeing is I can use this triangle here because, I know some information about this triangle. For one, we found up here to be 48 degrees. If you remember that, the angle between the tangent and the chord was equal to the angle in the alternate segment. We found this entire angle to be 42 degrees. So this whole angle was 42 degrees. But here we have 12. So 42 take away 12 will give us this part of the angle here. So I'll highlight the triangle. Okay, so this is the triangle that we're looking at. We know the sum of the interior angles of this triangle will be 180 degrees. And as I said, if here is 12 and this whole angle was 42, then 12 take away 42 is 30. Therefore, this angle here is 30 degrees. All right, so I'll just write that out, that angle MKL, all right, so angle MKL was simply equal to 42 take away the 12, which gave us 30 degrees. We don't have to write any reason for that because, we already found this angle. We already said that, this was one of the base angles of the isosceles triangle. Across here was 42, so here was 42. All right, so 12 take away 42 give us 30. So now we can say that the sum of the interior angles of this triangle is equal to 180 degrees. So we had to add the 48 and the 30 and take it away from 180, and we'll get this angle here. So angle MLK is equal to 180 degrees, take away 48 degrees, plus that 30 degrees. So that'll be equal to, all right, we have 180, take away, open brackets, 48 plus 30, close the brackets, and we get 102 degrees. So we have 102 degrees. So here's 102 degrees. Of course, the reason for this is the sum of the interior angles of a triangle is equal to 180 degrees. Okay, and that's your answer for MLK. So now moving on to part D, where we're going to find the value of angle KNM. So let's highlight that. Angle K to N and then N to M. All right, so this will be the angle that we want. And what I'm seeing here is that, we had the cyclic quadrilateral, and these two angles will be the opposite angles. of a cyclic quadrilateral. So let's highlight that. So there's my cyclic quadrilateral highlighted. And this is the opposite angle that I'm talking about. And if you recall, we found this entire angle to be 102 degrees. So we're going to put here as 102 degrees, which we found already. So again, these two are the opposite angles of a cyclic quadrilateral. Therefore, when you add them up, well, they are supplementary. So when you add them up, they must add up to 180 degrees. So angle KNM is simply equal to 180 degrees, take away that 102 degrees. And that will be equal to 180 degrees, take away 102, and we get 78 degrees. And our reason would be that the opposite, OPP for opposite, angles of a cyclic quadrilateral are supplementary. All right, and that's your answer here, 78 degrees for angle KNM. So moving on to part B, we have E, F, G, and H are 4 points on level ground. So we are seeing that E, F, G, and H, will be on level ground, being horizontal. We have the diagram below gives the information on the distances and angles between the points. Now we can see that here, 54 degrees, X, we have the distance 5.3 from H to G, G to F is 6.9 meters, and then H to F is 11 meters. Now this first question here, they want us to show that the value of X is 29.5 degrees correct to 1 decimal place. So we want to find the value of X. So what I would do, looking at this situation here, all right, this is a trigs question, which means we are dealing with a triangle, right? And the angle X is within this triangle here. So what I could do is draw this triangle separately. Okay, it doesn't have to be perfect. So here'll be 5.3 meters. Here'll be a 6.9 meters. And here'll be 11 meters. And here'll be an angle X. Here'll be H. Here'll be G. And here'll be F. Now, when it comes to our sine and cosine rule, these capital letters represent the magnitude of the angles, and the common letters represent the length of side. So opposite angle G will be common G, which will be 11 meters. So I'm going to write common G here. Opposite angle F will be common F, which is 5.3 meters. So this is common F here. And of course, opposite angle H, which is X, would be common H, which would be 6.9 meters. So that's common H. Now, we have all three sides. We don't have any angles. So the sine rule is out. So what we could do is use the cosine rule because we have all three sides to find this angle X. Now, we know the cosine rule. If you want the angle X, which is H, we must start with side H and end with angle H. So the formula is going to look like this. Common H squared is equal to the other two sides would be F and G. So F squared plus G squared. Take away FG, cosine angle H. And remember, angle H is this angle X that we want to find. So now let's put in the values. All right, so common H is 6.9. So we're going to have 6.9 squared is equal to, then we have common F. So common F is 5.3. So we're going to have 5.3 squared plus, then we have common G. Common G is 11 meters. So we're going to have 11 squared. Take away 2 times FG. So we're going to have 5.3 here times G, and G is 11. Then we're going to have cosine angle H. And instead of writing angle H, I'll just put the X. All right, so X. Now, what I like to do is to work all this out on the calculator. So I'll work out the 6.9 squared, write the answer here. Then I'll work out all this here. But remember, on the calculator, this goes together. Let's put some brackets. All right, so brackets here. So we're going to work out this, get the answer. And then we're going to work out this here, get the answer and write it down. Now, we can't get a full whole number for this because we have the cosine x. All right. So I'm going to put my equal sign. So I'm working out the 6.9 squared. So 6.9, we squared that. We get 47.61. All right. So we have 47.61. Then we have 5.3 squared plus 11 squared. And we get 149.09. So we have 149.09 take away. And then we're going to work out the 2 times 5.3 times 11. Okay, and we get 116.6. So that's going to be 116.6 and then the cosine x. So now these two terms are not like terms, so you can't subtract these two numbers because this 116.6 has been multiplied by the cosine x. So what you have to do is transfer this across here, or, you know, since this is negative, I could transfer this 116.6 cosine x across the equal sign, so it'll turn positive, and then this 47.61 across here, I will turn negative. All right, so this line here is the same thing that I have up here. I'm just going to do the transferring to show you. All right, so when I take this negative 116.6 cosine x and transfer it across the equal sign, this negative sign will change to a positive sign. So I'm just going to bring that here. And I'm going to take this 47.61, and this is positive 47.61. And when I transfer it across the equal sign, it's going to change to negative 47.61. And I'm going to bring it right here like that. I'm going to bring this here. And now, seeing that there's nothing in front of this 116.6, I can remove the positive sign. So now I can simply subtract these two numbers. So I have 149.09 take away 47.61. And that's equal to 101.48. So we have 116.6 cosine x is equal to 101.48. And now I'll transfer this 116.6 across the equal sign, and the operation will change from, 116.6 multiplied by cosine x to, the 101.48 divided by 116.6. Or I could say, divide both sides of the equal sign by 116.6. So either way, you're going to get cosine x is equal to 101.48 divided by 116.6. So x would be equal to the cos inverse of the 101.48 divided by 116.6. So x is equal to the cos inverse of 101.48 divided by 116.6. And that's equal to, all right, so I'm going to press second function, then cos. See cos inverse come up, open my brackets, and put 101.48 divided by 116.6. Close the brackets, press equal. And you see I get 29.50 and so on. So to one decimal place, this is just 29.5. So I'm going to get 29.5 degrees. And you see we have shown that the value of angle x is 29.5 degrees, correct to one decimal place. So moving on to part 2, we have a vertical tower GT is constructed at the point G. So at G, we're going to construct a vertical tower and is pivoted to the ground at the points E, F, and H. All right, so this is sort of like a 3D kind of shape we're looking at here. I know this two-dimensional surface can't really represent that, but E, H, and F is horizontal, and we're going to have a tower coming up at G. So if you read the question carefully, you see a vertical tower GT. So G going to be the ground and T will be top of the tower. So you're not seeing T here, right? So that's in G. So the tower is constructed at G and will rise up vertically to the point T. Is constructed at the point G and pivoted to the ground at the points E, F, and H using pieces of wire. So from H to the top of the tower T, you're going to have a wire connecting. I know you're not seeing the T, all right, but T is the top of the tower. F to the top of the tower T, you're going to have a wire connecting it. And E to the top of the tower T, you're going to have a wire connecting to stabilize the tower. Now we're saying that the angle of elevation of the top of the tower T, see, the top of the tower is T. Therefore, G is at the bottom of the tower. From the point F is 31 degrees. So we deal with F. This 6.9 meters will be a horizontal distance, okay, from F to G. So let's draw that out. So what we're going to have here is a vertical tower, all right, where, you know, here's the top of the tower T and the bottom of the tower is G. Then horizontally to the point F, all right, this is F. We're going to have that 6.9 meters. And therefore, the wire connecting F to the top of the tower is going to be this line here. And we're saying the angle of elevation, so from horizontal looking up from F, would be this angle here. So now the angle of elevation of the top of the tower T, so the top of the tower T, from the point F, from F, is 31 degrees. So you know the angle of elevation must be taken from a horizontal line. So horizontal line, and then from F, go up, is 31 degrees. Therefore, here is 31 degrees. Here will be a right angle. Because, you know, vertical tower, horizontal ground, 90 degrees. And the length of the wire used will be the length of the hypotenuse of this triangle, TF. So if you label the triangle, opposite the right angle is the hypotenuse. Opposite the angle that's given will be the opposite side. And the remaining side will be the adjacent side. So we want to find the hypotenuse. That's our unknown. We have our angle. We cannot use opposite because that's also an unknown. We could only have one unknown, and that one unknown is going to be hypotenuse. Therefore, we can't use opposite because, you know, to solve an equation with two unknowns, that'll be impossible unless it's simultaneous equations. So therefore, we have to use adjacent because we know the length of the adjacent side. So you'll ask yourself, which trig ratio has adjacent and hypotenuse? So, you know, you say SOHCAHTOA, toi, and that'll be Ka. Adjacent and hypotenuse is cosine. All right, so we're going to have cosine theta is equal to adjacent over hypotenuse. So cosine 31 degrees, the adjacent is the 6.9, and the hypotenuse is TF. All right, so we want to cross multiply here. So you're going to put the cosine 31 degrees over 1 is equal to 6.9 over TF. So multiplying cosine 31 by TF, we're going to get TF cosine 31 degrees, and 1 by 6.9 will just give us back 6.9. So now TF is being multiplied by cosine 31. So when we transfer the cosine 31 across equal sign, you know, it'll turn to division. It'll go under the 6.9. Or you can say, you know, divide both sides of equal sign by cosine 31. So what we're going to get is TF is equal to 6.9 divided by cosine 31 degrees. So TF is equal to, all right, we have 6.9 divided by cosine of 31. Make sure my calculator in degrees. Press equal, and we have 8.049. Now in the exam, you also want to approximate these answers to 3 significant figures. If it's an angle, you use 1 decimal place. So 1, 2, 3, stop at the 4. After the 4 is a 9, so we have 8.05. All right, so 8.05, and that'll be meters. So the length of wire that was used to secure the point T to the point F, that's the length of wire here, is equal to 8.05 meters. So next for part 3, we have the bearing of E from H is 228 degrees. Find the bearing of H from E. So that's the bearing of H from E. Now, we already have the note line on E. And we know bearings are taken in a clockwise direction from the note line. Therefore, we want to find this angle right here. So you see, from the note line going in this direction is clockwise. And this is the bearing of H from E. Remember, we have here that the bearing of E from H is 220 degrees. So E from H. E from H. So we have the note line on H, and we're taking the angle in a clockwise direction from this note line, and that angle has to be 228 degrees. So in a clockwise direction, we're going all the way around to touch here like that. And that whole angle has to be 228 degrees. Now let's just draw a separate diagram with this information. All right, so I have the line connecting E to H. I have the note line on E, the note line on H. Now, what I could do, since I want this angle here, is I could bring a straight line down like this. So this would be a straight line. So at H here, with the straight line, we'll have 180 degrees. And therefore, if I want this little angle inside of here, I'll put that in blue. This angle here, I would simply take away 180 degrees from this 228. So the 228 degrees, take away 180 degrees is equal to, all right, so we have 228, take away 180, and we get 48 degrees. All right, so this here is 48 degrees. That means inside of here is 48 degrees. So what we have here is a Z angle. This note line is parallel to this note line. And if we form our Z, here to here to here, therefore this angle here will also have to be 48 degrees because alternate angles are equal. And this angle represents the bearing of H from E. Let's just draw off this green line like this. Put a blue line. Clockwise direction, 48 degrees. So the bearing of H from E is equal to 48 degrees. So for part B of part 3, we want to find the bearing of G from H. So that's G from H. So we have the note line on H. And if we go in a clockwise direction to the line touching H to G, that will be the angle that we want, the bearing of G from H. So that angle will be this angle here in a clockwise direction. All right, so let's just draw this situation separately. All right, so I have my note line on H. I have this line connecting to E and this line connecting to G. Now remember that we have that the bearing of E from H is 228 degrees. So what we have is this whole angle here is 228 degrees. All right, so here is 228. Then we have this angle 54 degrees, which is angle EHG. So EHG is 54 degrees. So we put that in, 54 degrees. All right, that's from here to here. Then think about it. If this is the angle that we want, let's put that in green. So we want this angle here, in a clockwise direction from the note line. All we have to do is take away the 54 from the 228, and we get this angle here. So we're going to have the bearing of G from H is equal to 228 degrees take away 54 degrees, which is equal to, all right, 228 take away 54 degrees, and we get 174. So we have 174 degrees. All right, so here I'm going to write 174 degrees. And therefore here we also have that 174 degrees. All right, so my bearing of G from H is 174 degrees. And this will bring us to the end of this question 9. So stay tuned for the next video on question 10. Of course, question 10 will be the last question for this paper.